Woo! Woo! I'm back. I'm back and I'm convinced. No, I'm not convinced. I was gonna say this is our last Space Tour Truck video perhaps, but I don't think it is now because there's a World 8 unlocking. So let's just dive in and see what we can get done. Let's dive in and see what we can get done. I did the last video I did today as well, and then I just played some Get Tools Up with Kim. And then I said, I want to go back. I want to finish this one. I want to play more of it. So we've got 7.17 should I say. Oh, this looks like one that we've already done. So we want to be driving in here and then get hooked into a black hole here, right? So we want to be minus... Oh, we can't go any further back. So we actually want to do the black hole and then shoot off. So we want to start here on 1520. 1520. And then we want to be going out here at, let's say, 10. So minus X on 10. 6 seconds. Oh, we have 2 black holes. So I think what we actually want to do is just remove the black hole after so long. But what we need to do is find out. So the black hole needs to be here. The first black hole needs to be here, which is 15.5. 15.5. Let's do some calculations here, shall we? So if we're going at 10, let's just say we're going at 10. The radius is what? Sorry, 15. The radius is 15. 10, that's 6 seconds. We have 14 seconds. We could make it, 15 seconds is too much, so it has to be here. So we were correct. That is 6.67. 6.67. Great. 1510. Then it's a full one. So 1510, that's 9.42. We want this to be 9.4 seconds. 9.4 seconds. And then we actually want to just reduce this back to nothing, right? We don't want this black hole to exist. And that should be that. We should come around here and then fly off at the end with a straight velocity. No more black hole messing us around. Look at that. Goodbye, black hole. Goodbye, black hole. Another level down, another level completely crushed. Black holes are too easy. We didn't do it. We didn't do it. In that case, was I going too fast? I didn't check. God damn it. I thought let's do it again. Minus. Oh, no. Where are we starting? We're starting 1520. God damn. 1520, put this in really fast, minus that. We have this 9.4, 9.4, and then we want this to be 15.5, and we want this to be 6.67, and then we want this to be 0, 0, and 0, 0, go. Alright, what was wrong with this? Were we too fast? Were we too fast? Seems like that's going to be what happens. Because yeah, 9.6, and we've still got a couple of seconds to survive. So we crashed at the end. Okay. So we actually want to be going slower then. We actually want to be going slower than that. We want to be going slower. But if I go any slower, if we go here, we go slower. No, wait. If we go slower, that's 18 seconds. That's too much. So we have to do the 9 seconds. The 18's way too high. So we can't do that. We can't do that. What we might need to do instead is, what if we actually start up here, 3020, and then we come into the black hole, and then instead of this being 940, it's we're gonna spend an extra 1 second, 1.5 seconds basically. So let's go to 9.9. That's 5 seconds, and then 10.9 as 1.5 seconds. Think that'll work? Oh no, it's still grabbing us from there. Is the black hole? Okay. So we can't do that. 9.9 it is. It has to be the 9.9. 9.4. Blah blah. 9.4. We go from here. We spin all the way around, and then it lets us go. But we can decrease. What we could do is, can we do half and then half maybe? What do you think? If we did half and half, 9 for half. So if we did, what if we did half fast and then half slower? So if we did, that seems about right. Let's try that. We start in the same position. Both black holes are going to be in the same position. And then what's going to happen is we have this half. So here to here. And if we're going at 10 and the radius is still 15, that's 4.71. So if we do go, we don't increase our velocity though. Our velocity has to stay the same. So if we actually just did this as 4.71 and then again as 4.71, doesn't really make a difference. So how do we die? Oh yeah, crap. We need to let's reset this because I wish I could just reset. 9.4 it was supposed to be, yeah. Let's just reset. Can I reset you? Can I reset you back to 0? I wish there were just a reset. Let's just try this again. I want to see what happens. And it's annoying to have to... Oh, crap. Nope. I was correct. It's what is it? 15. 15, 20. We go around the black hole. So this is the correct way to do it. Instead, what we should be doing... Oh, because minimum is 0 here. So we crash. Because I was going to say instead we start here, but we also can't do that and then come in. But we also tried that one, and that doesn't work either. So we need to survive a full extra 1.4 seconds. It's quite bad. We could go here and like do a full circle and a quarter basically. Let's do that instead then. Let's go... Oh no, because it has to be here because we need to be going X. Positively on the X, but then is it going to shoot us back around? Okay. I think this is actually going to not work because we're going to get here and go backwards. But let's just try it. Positively on the X for 10. We're going to start at 15 minus 10. 15 minus 10. We're going positively this way. And then from, it's actually 9.4 plus 4.5 plus 2, 4.7, right? So, ooh. So if we put in the let's put in the 7. So we've got the 10.1, and then plus an extra 4. 4 point. Oh, we can only go to maximum 12. We can't do that. We need to be like, yeah. Oh, this one can. No, because then we want it to disappear, don't we? You see what I was trying to do? What I need to try and do maybe is do this. But I can't go that far, can I? 35? Oh, I can. We can go to 35. So 30. 35. And we have positive on the Y. And for this and a quarter, so for 9.4... and a quarter, so another 1. Oh my god, this is just insane. Let's just look at this quickly. We're going 10. It's 15. 2.36. And a half is 4.71 and 9.42. Yeah. So an extra 2.4. Okay, so 11.8. Let's do that. And that's going to be the gravitational pull of 10, 15, 6.67, and then this just disappears. Let's just see. Why am I down there? Why am I down there? Excuse me? We need to be at 30. Oh, I went to 35 minus 5. What the heck? Here we go. Just gives us 1 extra quarter of a circle of time, which is 2 seconds, which is exactly kind of what we needed to cover. Because that disappears now, and we shoot off. Okay. We did get it. We did get it. Okay. But we did start to move away then from where that was. Okay. We just needed the extra quarter. That was nice. I like that one. Mary Curie, the physicist and chemist, was not only a pioneer in the study of the phenomenon of radioactivity, but also discovered 2 new atoms, radium and polonium. In addition to being the first woman to complete her doctorate in France, she is the only person to have received 2 Nobel Prizes, a prize for people who have made an important contribution to humanity, in 2 distinct fields, in physics and in chemistry. Her daughter, Irene Julio Curie, also received a Nobel Prize in Physics for her research on radioactivity. I didn't know that. I didn't know her daughter did that as well. During World War I, convinced that X-ray radiography, or X-rays produced by radioactivity, could save lives by more easily locating fragments of metal in the bodies of soldiers, she went to the front equipped with X-ray machines. Wow. Coming from a poor and bereaved family in a country subjugated by Russia, she takes the cheapest ticket to Paris to go there to study sciences, women not being accepted at the University of Warsaw. Wow. Very curious. An inspiration. Serious. Phenomenal. Phenomenal, some people, aren't they, really? Okay. We want to change our velocity? It seems like what we want to do is just do this in a really slow arc. But maybe we want to do a quarter. And then a really slow quarter. That seems weird to me. That seems weird. Okay. Initial position, yeah. -30, 10. And we're going to go -5 down there. Let's do... Because it is a quarter, and then we can change velocity as well. So let's do a quarter turn. A quarter motion. At 5. And the radius is... In fact, what is the radius? I can't see. 1, 2, 3... Okay, so 15 to 10. 25 radius. So we actually need to place the black hole as well at -5, 10. And that's 5, 10, 15, 20, 25. Yes. 25. So we'll check it first. That's 25 radius. 5, that's 1. Done. That's a quarter. That's 25, 5. That's 7.85 seconds it would take to get here. And then if we do the next one, so we can do 7.85. So actually, if we do this one fast instead, like 2.26. So we have 10 seconds. So 2.26 plus 7.85 is what we actually want. So we want to do it like this. This needs to be 9. And then we want to change this to -15. And that's going to be for 2.62 seconds. So 2.6 seconds. 2.6 seconds. Here we go. 2.6. 2.6. And then that's 2.6. And then at 2.6. Make it match that. Then we want to be going... Oh, then we change to X. So we're going to be going positively on the X by 5. And then this is 1. As far as I remember, this position is going to be the same. So -5 plus 10. And that seems about right to me. That's 5 and 25. Yeah, let's go for it. So you should go really fast here and then really slowly here when this changes and we change. Boop. Sweet. Black holes, the physics and math behind black holes, we've stomped it. I'm sure it's just as easy to do this, you know, in university. Here is Henrietta Swan-Leavitt. She is the best known of the Harvard calculators. Her article on variable stars, stars whose luminosity oscillates in time, was the trigger which made it possible to estimate the size of our galaxy and to understand that our universe is gigantic. It was Edwin Hubble, using the variable star technique proposed by Henrietta Swan-Leavitt, who realized that all the spiral-shaped nebula that can be seen in the sky are in fact galaxies like ours, but incredibly far. His analysis of these galaxies allowed him to understand the universe is not only large, but also expanding. He had just discovered the Big Bang. After studying astronomy, she offers her services to work as an assistant at the Harvard Observatory, but can only work as a volunteer. Soon after, she fell seriously ill and became deaf. It was only 7 years later that she resumed her work at the Harvard Observatory with a permanent position, and this time paid. During her lifetime, she received no recognition or honor for her work. It was only after her death that she became famous. What a scam. Horrible to hear that. It's always horrible to hear. You always hear artists, poets, and mathematicians and scientists just get ripped off like that. This looks like a double black hole. Okay. So it looks like we want to go whoop, whoop to me, like an infinity symbol. So let's go minus 20, minus 10. Minus 20, minus 10. And then I suppose we want to go positively in the y direction. 5. We have 9.4 seconds. So we need to be doing this. This is what as at 5 here. Wait, where are we? 5 and 5 is 5. So this needs to be at 5. Then at a full circle, 5, 5 is 6.28. So we want one of these, a fast one and a slow one. Let's do the slow one first. 6.28. So 6.3. And that is going to be positioned at minus 25, minus 10. So we are going to shoot around here. And then when we get back to here, our velocity, we're going to be shooting off here. So then our velocity is going to be... If we're going around here and then we're shooting off, we still want to be going positively in the y direction, right? But we can start it again. So we're going to be going, once again, plus 5. We actually want to go plus 10 this time. Delta velocity, so just plus another 5. And that is 6.3. 6.3. And here, another circle. So that's 5 radius, 10. That's 3.14. That's, of course, the time, which is fine. And then it's also, we need 20. Keep them in tight. And this one's going to be minus 15, minus 10. I'm thinking this might be a little bit wrong, just because this delta velocity might screw us up a little bit. See, I might have made a mistake there, but we'll see. No, we got it. We got it. Okay. Sweet. Sweet. I'm getting so many messages. Let me just check. Oh, it's Kim sending me sending pictures. Sweet. I'll look at them later. What's this? Luna 20 landed on the moon on February 21, 1972 as a second unmanned probe to bring a sample of lunar soil back to Earth autonomously. It only brought back 30 grams of lunar soil back to Earth. And Lise Meitner, she was a pioneer in the study of radioactivity and in the discovery of nuclear fission, a phenomenon by which a large atom, such as uranium, breaks down and releases a large amount of energy over its half-life. And then while she was head of the physics department at a research institute, she had to flee Nazi Germany to work in Sweden. Unfortunately, without a laboratory and assistance, she could not carry out her research as effectively as she did in Germany. Her longtime colleague Otto Hahn, with whom she worked extensively on the discovery of nuclear fission, was the only one to receive a Nobel Prize in chemistry for his work on nuclear fission. Several scientists at the time, including Niels Bohr, disagreed with this decision. In his honor, an atom bears his name today, the Meitnerium. That is so BS. We should call it the Meitnerium now. Nah, they could share it, right? You've got to split your name in half, add it together, and call it that. So this seems like, because of these bombs, we actually want to start here. And then come down here. So what I see is a black hole. We want to be at minus 5. And we want to be going at positively y. And we want a black hole at 0, 0. And a quarter of a turn at 5 radius going 5 is 1.57. So that's 1.6. And then here, that's 5 and 5. That's 5 here. And yeah, so that's for 1.6. And then when we're here, we need to do another quarter. And that black hole is going to be minus 0, minus 15. There we go. 0, minus 15. And it is 5, 10, 15, 20 radius. So 20 radius. In fact, how fast do we want to go? Because we've got 4.7 seconds. We've only used 1.6. So we are going, it's 20. We need to go 3.14. So we need to be going at 10 now. So this is at 1.6. We need to be going at 10. Positively in the X direction. And then the black hole needs to be down there. And because it's 10 and 5, 10, 15, 20, 10 and 2010, then it's 2010, and it needs to be a 5. Alright, let's just try that out. Heyo, and done. Heyo, I think we're just too good at these ones. I don't know why. These ones have clicked with us. These ones have been very simple, I think. Because we have the graph, these are like marked at 8s and 9s. Like, I don't believe it. These ones aren't as hard as some of the other ones because the charts are there for you. You don't really need to think about them. Meet Emmy Noether, one of the greatest mathematicians of all time. She discovered an important theorem which allows to link two pillars of physics, the concept of symmetry and that of conservation of energy. Although great mathematicians like David Hilbert and Felix Klein recognized her genius, she had great difficulty in being accepted in academia. After her doctorate, she had to work 7 years without being paid. The great Albert Einstein recognized her creative genius in mathematics, I'm pretty sure it means. Moreover, the importance of Noether's theorem in mechanical physics is often compared to the importance of the Pythagorean theorem in geometry. Alright, Emmy Noether. Let's go. Let's move on. Next puzzle. Oh, look at that. It needs to get tighter and tighter. So we've got 2 half turns. Oh, do you know what? I feel like this is a half, this is a quarter, and this is a quarter. So let's see, we've got 3 black holes. Yes, we do. So perfect. We're going to start at minus 20. Our velocity at minus x of 10. We have 10.3 seconds, so we need to be careful here. A half turn at a radius of... So this is going to start at 0, 0, yes. And it's a radius of 20. We don't have very long, so we should go at 15 probably. So let's say 4.19. We can't do 4.19. We've got to do, what is this? This is the time. We can't do that. We've got to do 3 seconds. So we should actually work as, that's 3 to 5, and we, okay, yeah. So we actually want to work from here outwards. So we're going to start at minus 5. Let's go back. We're going to start at minus 5, 5. We're going to be going positively in the Y direction. And the first black hole is going to be at 5, 5. We'll reset you. And that is a radius of 10. Radius of 10 for a quarter turn. Radius of 10 for a quarter turn. Radius of 10. That's 1.57. That seems fine by me. 1.6. Let's go. 1.6 because we can't do 3.14 anyway. So 1.6. And then we go back to here. And that is a radius of 10. And a, what did you say? A quarter? And that's 10 as well. So we actually need to be going 10. Quarter turn. 10. 10. 10. 10. That's power of 10. Here we go. Not power of 10, sorry. The gravitational force is going to be 10. The power of the number 10, not to the power of 10. Let's go. And then we are going to be here. And we want to move down to here. So this is going to be 0, 5. This is 0, or 5, 0. That's the new one. And that's a radius of 15. So let's look at this one. This is a radius of 15. So another quarter. And we can do that with 4.71 seconds, right? 4.71 seconds. So from there, plus 4.7 seconds. So let's go up to, we got 5.6. That's the 4. And we're just gonna, yeah. And then we got 6.3. I think we're doing that correct. And then here, that is what we're saying. That's a 4.71 because that's a speed of... Oh, we're still going 10. We're still going 10, actually. We can't control it anymore. So we're going 10. That's only going to be... That's going to be 2.36. So maybe we need to... Do we need to go 5? We do that first quarter turn at 5. We can't do this. Oh, we can! No, we can't because we only got to 3. We only got to 3. So, okay. So it is the second one here, the radius is 15, and at a speed of 10, it's only 2.3 seconds. Okay, 2.3 seconds. So actually, we want to go way down. Let's go 3.6, that's 2. And then go by another 3. Okay, we're on to 3.9 seconds. And the power of that, 1510 is 6.67. Alright, 6.67. And then when we're here, after, 3.9, we're going to do a half. And that radius is 20. And we need to do that over 6 seconds. And we're still going to be going 10, so that's correct. So that's going to be 20. That's actually going to be at 0, 0, so that's perfect. And because we're at 2010, that's 5. I think that is the calculation complete. Let's go. Look at that. Too easy. Black holes are easy. It's the easiest part of the game. I don't know why. I don't know if I've just clicked with these, or maybe I think these should have been in a different order. I don't know. I found these to be very simple. Louise Freeland Jenkins. She helped to measure and calculate the position of about 350 stars neighboring the sun, thus providing the first three-dimensional maps of the position of the stars around us in our galaxy. 3D maps of stars in the galaxy. That's insane. Oh, it looks like now what I want to do. That's 0 to 10 seconds. Because I was thinking we go up and then down, right? Like, but we can't do that. Huh. At 4 seconds as velocity changes, we can change that to whatever we want. So we have an initial velocity. We have 10 seconds here. How long is a quarter of a quarter turn? How long can that be at a radius of 20? Because obviously this needs to be at 0, 0. The radius of 20. So if we take this at 6 seconds, 6.2 seconds. So, and that is at 5. Right? That's at a speed of 5. So if we're going here. Let's say we're going this way first. So we go positive 5 here. And we go, you know, positive 20, 0. So we're going up here. This is going to take... Oh, wait. We need to check the power of the black hole as well. That's a radius of 20. We're going 5. That's 1.25. So we're going here. And then after 6.28 seconds, we're going to be here. So then at 6.28 seconds... 6.3 seconds. We want to be able to go negatively into the Y. But the black hole's still going to be there. So, will that just pull us in though? Directly? Because we're heading straight towards it. So maybe we just put this as -5 and it'll pull us in slowly. Let's see. I'm very unsure, but we'll see. Because it should just slowly pull us down. Yeah, can we do it? We can't survive fast enough, though. We can't survive fast enough. So maybe we need to do the velocity going away from it first. Oops. Excuse me? Did that count? I need to see that again. That counted as we succeeded. Is going into the black hole correct? Oh my god, no. It didn't. Okay. So where were we? We were at 20, 0. Our velocity was at positive Y. The black hole was there. And this had to be... Oh god, what was it? A quarter thing at 20. 6.28. But here it was 1.25. Yes. And then the velocity here was just straight down -5 at... What was it? 6.3 seconds. Let's go. So we had 10 seconds, but going into the black hole seems to have worked. Because look. But we didn't die. It didn't kill us, though. That was just tricking us. All right. I was like, well, you're in the black hole. We don't know what happened to you. But you succeeded. Here's Priscilla Fairfield Bock, an astronomer. There's no picture of her. Oh. An astronomer, author, and popularizer who, together with her husband Bart Bock, greatly contributed to a better understanding of the shape of our galaxy and how the stars are distributed in it. The couple also discovered that new stars are still forming today, when it was thought at the time that all the stars in the sky were formed early in the history of our universe. Right, these are level 9 ones now. These are difficulty 9. Once again, 30 minutes in though. We're doing well. Ooh. Ooh, this does look nasty. We've got 3 black holes. 3 black holes, a single starting position, and a single velocity. So we can go around here. No, doesn't have to pull us in. This one's gonna be hard. This one's gonna be really hard. Ow. So these are 25 away. This is 20 away. This is 5 away. We have 13 seconds. I feel like what I would need to happen is this quarter, this half, and then I honestly. Let's just try and do some stuff. I think we just try and do some stuff. First, let's say this quarter here. Let's say I start at 0.25. And I want to do a quarter turn, so I'm going to go minus X on 10. This black hole's right in the center, and it's got a radius of 25. Radius of 25, I'm going 5, I'm going 10, that's 3.93. So we want 3.9 seconds. It's going to be 0, 0. So we're going 10, radius of 25. That's 4. Did we do that actually? Radius of 25? That was 3.93. Yeah. So then that brings us down to here in 3.9 seconds. Then we do half. Is this... This doesn't work on half, right? Because 25, we're going to go here. But then we need to be tighter here. Yeah. We only have 3 black holes. This is 25. This is 20. This is also 20. What if this is minus 25 and I start at positive 25? I'm not going to hit that, am I? Going up to here. Maybe we do this as a half. Let's do it as a half. So half, we have, it's a radius of 25. Or 30 maybe. No. Let's do a radius of 25. Oh, we can only do 25. Do a radius of 25. It starts in 0, 0. We start at 25, 0. Or 0, 25. 0, 25. And we're going this way. And this is going to pull us around. We want to try and get these 2 bars at the same time. The black hole is in the center indeed. But because we are going at 10 and the radius is 25, that's 7.85 seconds. That's quite a lot. Maybe what we want to do is actually speed this up. 15. And have it as 5 seconds. 5.24. So let's do 5.2. And if we do this, 25, 15, this needs to actually now be 9. And I just want to do a quick test. See if we actually do collect those barriers when we do this. And we do. Perfect. Perfect. And then, when we get to here, we need the quarter turn to pull us in, like, to somewhere else. We get to here. And if we put, like, one here, We could get we could get like a half turn to here. So I end up here. I could go to here as a half turn, right? 5, 10, 15. So we want to be 0, minus 10. Let's do that. We want to be 0, minus 10. So this one's done. This one's 0, minus 10. We're still going at 15, by the way. We're still going at 15. So 15, and this radius is going to be 15. That's 15 power. 15 power, like the gravitational pull needs to have a power, like, needs to be 15. This is going to be a half one as well. That's going to be 15, 15. That's 3.14. So go to 8.2. And that's the 3. And then it's just an extra 1. And then we should end up here. Right? We should end up here. And then 15, and that's at 8.4. So then we need another black hole. If I end up here, and if I put a black hole to like pull me back the opposite way, so this one goes to 0, 15, and we have basically the same black hole again, but you know, going the other way. So we go whoop whoop. We go we go like whoop, whoop. Okay. And that, so let's do the same thing here. This needs to be at 15, 0, 15. We've already done that, and it needs to be a power of 15. Let's just try this. So we want to come around here, land here, and then get arced into this. No, because it's pulling us around slowly. We do hit that though. We do hit that second one, we just don't get the first one. What? It's because this difference here can't just be pulled this way, you know? We can't just be pulled that way. But if I did a black hole here and did this, where did we end up at the end of that? Way far away. But if I actually did it here and went like this, and then did another one here and went like this, slowly, and then shot off here, would that work? Let's try. Let's try. Okay. So let's say we start instead, we start at 0, 25, so we still start in the same place. But the first black hole is at 0, 15. It's at 0, 15, and we're traveling a lot slower. We travel at 5. So we're doing a half circle. And the radius is 10. And our speed is 5. That's 6.28. If we do 6.28 and then 6.28, and then this is 3 more seconds, that's not going to work. If we do it at 10, 3.4, and then we do it slower on this one to 6.8. So let's do this one to be slower. Oh, we can't do it to be slow. It's going to be 3.14, 3.14. And then 1, 2, 3. Still going to lose. Okay. We could extend it by making this a full circle. Going at 10. 10, 10. And we start here. We start at 0, 5. We're going at positive x at 10. This black hole is the same, but it's going to last us 6.28 seconds. 6.3 seconds. And then, so 0, 15, yeah. And it's going to have a power of, so the radius is still 10. And the speed is 10, so it's going to have a power of 10. The 6.28 seconds, we're back here. Then our second black hole, which needs to be midway between this and this. So, oh no. We can't do that, can we? Could get it to here. And then tighten it up again, maybe. So we have another black hole here to pull us around. Okay, so we do use all 3 black holes. Let's say we do this. So we come back to here, and we add a black hole at 0, -10. Perfect, that's where it already is. And we want to do a quarter, a radius of 15, and a velocity of, we're still going at 10. So 15, 10, that's 2.36. So 2.4 basically. So that's 8.7. And that's going to have a power of, so what is it? It's radius of 15, 10, 6.67. It's going to pull us down here. And then we have a third black hole. A third black hole. Which is here. We can't shoot off from the black hole though. What am I talking about? I've just broken my own brain. Of course we can't do that. We can, this half circle here is great. If I end here, that half circle is fantastic. And then coming back around this half circle to get this was also awesome. But then if we move it and come back around here, does that work? Like if I'm here and we put one here and spin it around again. So we go here, boom. And then we go here, and then we go here again. So, well, all right, let's try that then. We start, same as, we're going to do this same one then. We're going to go 0, 25. Then, velocity of -10. This first black hole is at 0, 0. And that is a half turn with 10 and a radius of 25, 7.85. 7.85. That's fine. 7.85. So we know 7.9. And then here, 25, 10. That's 4. Okay. And then we get to this point. Boom. Now we're here. We want a black hole at 0, 10. We want a black hole at 0, -10. This is exactly what we wanted. And this is another half turn. And this is 10 again. And the radius now, though, is 10. 10, 10. 3.14. So we want an extra pi on this. So it goes to 8 is the... Oh, is the one extra. And then we want to go to 11. It's not. It's too fast. Oh, no, it's not, because we've got 13 seconds. So we want to go basically, we want to be at 11. Oops, 11. Oh, miles away. And the power of that black hole at 10, 10 needs to be 10. Then once we're here, can we put the black hole... Oh, no. We want to do this as kind of 3/4, don't we? Can we do this as 3/4? I know it sounds crazy. But if we add an extra quarter onto the time here. So, what is it? 10, 10? Is the radius... Wait. The radius is 15, isn't it? 15, 10. So actually it's 4.71. Maybe we need to go faster then. Let's go up -15. This first black hole, we're going at 15 and the radius is... What was that? 25? So 9. And that's a half turn, so 25, 15, 5.24. So we'll go to 5.24. 5.2. The next one, which is here to here. Let's say it's still in the same position. The power of it is now we're going 15 and the radius is 15. So 15. Then the time is a half and a quarter together. So it's 15, 15, 3.14. So that's 8.3. Let's go 8.3. Plus 15, 15, 1.6. So we go to 8.9 and we go to... Oh no, 1.6 actually. What were we on? What were we on before? God damn it. Damn it. This was 15, 15. 3.14 from here. We were on 8.3. And this is 6 to 9. And it's 1 point. So 9.9. And that 9.9 should bring us to here. We'll be here now. So then we want a black hole to swing us into this. How do we do that? So we're here, and now we need to come around to here. That seems unlikely. Huh. Here? No, here. The black hole's already here. We're going around it. Whoa. We're going around it in this circle. If we just move it up, does it pull us in? Let's do like the same thing. 15. And we just move it up like to -5. And that's it. Let's just see what this one does. Because this should work. We should get here, here, and then here, here. We should get to here fine. We should get to here absolutely fine, but the third black hole is what's gonna maybe screw us up. Yeah. We need more time. Or maybe we can have a... Because it's like a half turn, right? We're going at 15, and the radius is still 15. 3.14. 15, 15, 15 power? Yeah. What if we pull into 20? Now I'm just testing stuff instead of actually trying to figure something out. Because maybe there's a better way to do this. But what we were trying to do is find what kind of circles can we get used on. But this looks... Oh, close. That's when we start getting into ellipticals, you know what I mean? We go to 15. What if we just move it up again? It pulls us a little bit stronger. It could work, yeah, it could pull us back around on track. Yeah, we just needed to move it up a little bit more because we needed more time to get onto that right track. Okay. That one was a tricky one. That one was tricky. I'll admit it. That one stumped us for a little bit there. That's Gertie Theresa Radnitz Corey. Together with her husband Carl Ferdinand Corey, she discovered how sugar is assimilated in the human body and how it produces energy, what we now call the Corey cycle. I didn't know that. After Mary Curie and her daughter Irene Juliet Curie, she's the third woman to obtain a Nobel Prize in science medicine. Okay. Last difficult black hole specific thing. Okay, straight away I see 2 black holes. We have 2 black holes, so that's fine. So this one doesn't seem all that complex, to be honest. Oh, it is though, because this black hole is not going to be in the center here. So we're going to collect all of this easily. And then we're going to have a weird thing going on here. Alright. So let's just do that then. Right, let's actually go here first. So we're going to start at -20. And then we're going to go positive velocity of y. This is going to be right in the center. We've got 20 seconds, so maybe actually 5. We want to do a full circle. We've got a radius of 20, the speed of 5. That's 25. Wow. Actually, that is too fast. 12 is what it's going to have to be. So 10. 12.57. 12.6. So we can do this for 12.6 seconds. 12.6. That should... No, that'll bring us right around to there, actually. We don't want to do that. We want to do 3/4. So if that's 20... If our speed's 5... And this is 20. 12.57 plus 6. So that's, let's say 12.6 plus 6.3. Yeah, it's still too tight. So we still probably want to be on 5. But from here, we could still do a full circle if we wanted to come back from here instead. If we needed the numbers. Maybe we should do that. Because then we know it's exactly 12.57. 12.6, yeah. Let's do that then. Let's try to start at 0, -20 with a velocity of positive x, negative x, should I say. I'm gonna push out here and it's gonna pull us around. Then for 12.6 seconds, this little black hole is, what is that, 20, and we're going at speed of 10. It's power of 5. There we go. After 12.6 seconds, we're going to reach back here again. Boom. And then from there, we still have pretty much... We have 7 seconds left about. Let's say we have 7 seconds. 7 point something. Right. And this black hole's weird. Where's it going to be? Because it's not right in the center of something now. So we go around here. Here. If you do it at -10, -10, and we can make it like it's kind of elliptical. Let's do it -10, -10. No, it should be at -5, -5. Oh god, no, 0, 0. -5, -5. Whoa. We can go into ones now. Oh, well, we want to go 7. 7. Oh, so it is easy then. This is easy then. Oh, I thought it was going to try and trick us with something. So, okay, and then we're here. And this black hole is going to appear. And then we're just going to go around this circle as well. So, what power do we want this to have? This is another one. We kind of need it to be like the 7, right? So... Radius of 5, but it's actually not. The radius is what, 14? 7 to 7. Yeah, so the radius is 14. So it's going to be in the middle of here. No, well, no, it's going to be closer to here. So let's say... we're doing 10, a speed of 10. So here... Hopefully it's just enough time. Seems about right. Seems about right. But then the power of the black hole... is going to be awkward, because now we want it to be around 6.67, but not quite, right? But we can't really do anything about that, so let's just go for it. We start here and we go all the way around. One full cycle. Then the black hole moves here and we go around this little area. But the gravity might be awkward with us because it is not the correct exact thing. Yeah. Yeah, so we're going to have this, like, ellipsis. Okay. So, instead, because this is the last one, I think what it's going to try and get us to do is maybe we need to move at a speed of 5. So if we go back to here and we do half at radius is 20 and 5, that's 12. But then if we do a quarter, that's another... Oh, it's still really... Yeah, no, that we can't do that. 18... Pretty much, yeah, it's 19. We have 1 second now. So it has to be a speed of 10. We have to be going 10. Maybe we do this first little circle. Huh. I've put this down a little bit just because I feel like this, it can't be the 6.67, so we'll go down to 5 instead and see if that just does anything different. Because yeah, it's not strong enough now. Now it's not strong enough. 6.67 whipped us around too much. So the speed is bad. The speed is bad. Alright. But we can do it. This one's tricky. This one's tricky. It's obviously going to be the last one we do today. This one's a little tricky one. Because it's putting us off center, which we're so used to now. The black hole's in the right place. And if we started on... Let's say if we started on 0, 0. Let's say we started on 0, 0. And we actually went off at like positive x minus like this. And made this black hole, so this one can't do that. So it actually does, it definitely wants us to do this one second then, obviously. So, alright, so never mind. I'm thinking this 20 here, if we're going 10, the 6.28 and the 3. Do we actually only want to use 9 seconds? Or is the full circle better? I think the full circle is probably better. Because I don't think we're ever going to use the 20 seconds. But let me put this back. Where were we? We were 0 minus 20. And we were going at negative x. We're going at negative x for 12.2 seconds. 12.6 seconds at 5. Because it's 20. And we're going at 10. That's 5. And then when we get to here... Say it's... Can I play it again? Here we go. So we go around, boom. This is perfect. And we get to here, and that black hole... We collect that battery as we come back this way. And then, that black hole, it appears... Does it appear too late? No. Doesn't appear too late. But we do careen off of it because we're going too fast. But if I do it like this, 9, it's gonna be too much then, right? But let's see. Let's see what the elliptical form does. Because this will be way tighter. It's gonna pull us in like this, yeah. Oh, but if we do it at 10. Okay, let's do this again. I'm wondering if it does keep sending us around and collects these batteries, and all we need is time. We can get more time by only doing the 3/4 here, which would be good. And if we absolutely have to, we can even go at more speed, but this elliptical here. Is that gonna work if we have more time? We could do. We could do. So let's do it. Let's do it. Instead of this from 12, we're actually gonna start at minus 20. 0. We're gonna be going at positive y. The black hole is not gonna be for 12.6 seconds. It's actually gonna be. So we're still going at 10, and the radius is still 20, but we're going at 6.3 plus pi. So instead of doing 12, what we're actually doing is the 9.42. So let's put that in. Yeah. So 9.42. 9.4, and then Let's try. Just have an extra 10 seconds. We have an extra, well, we have an extra 3 seconds, but let's just use that 3 seconds to figure some stuff out. It's still a flam trying to trick us. Yeah. Now, what if we do that same thing, but we want even more time? We go at 15. So, we're going at 20 and it's 15 now. That's 4.19 plus 2.09, so 2.1. So, whoa, 2.09. All right, so we've got 6.3. So we only need this to be 6.3. Okay. And because we are now going at 15, and this is still 20, it's 11.25 strength here. And then, pretty much the same thing. Oh, no, because we need to increase this one as well, probably. Yeah. Oops. This is not going to be good. Yeah, it's not strong enough to pull us back. Let's go. 15. Because we need as much time as we can, basically, to keep, you know, shooting around this black hole in these ellipticals. Wow, no. Stronger. Stronger. Strongest it can be. Strongest it can be. Can't do anything else now. This is the last try of something that I might understand, and then I think we need to look at the entire thing again if this doesn't work. Like, the entire puzzle again. Seriously. Come on. It's gonna get it. Oh! Oh my god. Oh my god, that was coming for it. That was definitely coming for it. Can we save any more time? We already start here. We shoot around here. And then we start doing these ellipticals. We can't go any faster. We can't go any faster. This is working though. This would work. Look at that. We're coming right back for it. We're coming right back to spin through there then. Oh gosh, darn it. Damn it. That one's a good one. That one's a really good one, but I think we need to come back and have a real look at this one because I think we need to re-establish what's going on. Because we can get this outside one, and we have to get the outside one first because this is the one that we can mess around with. But doing it as -7, I think is correct. Yeah. And trying to get there as fast as we can. I just don't know what we need to do now to get these. Because it's almost 15. Let's say it's 15. And our speed is 15, so this needs to be 15. Is what it's saying. And then because it's this, it's going to be 6.28 seconds, 15 on 15. But it just doesn't work. It shoots us off. Because we're not completely on track for it. Yeah, and then we crash. So I increased it just to pull us in stronger, but then it starts with the ellipticals. Okay. You know what? What about if we start it? Oh, we can't start it later because it'll make this start later. Okay. So what if we do another? What's a quarter of this one? A quarter of the 20 radius, 15 speed is 2 seconds. So 2.1 seconds. So if we do it just an extra 1 second. I can't remember what this was now. That's 6.9. Have I just killed myself? I think it was 6.9. No, wait, what is it? 6.3. So if we do 7.3. So that we're like here when the black hole appears. Then we should be like in this, you know, in a better position for it. And then we're here. And then we should just pull around, right? It should just pull us around. It didn't. But if we increase it, the strength, maybe it'll pull us around better. You know what I mean? So I'm doing a full 3/4 and then plus an extra 1/8, basically, to get here, to help this one pull me around a little stronger. Is that not? Seems like it's oh no, because now we're actually in its pull. Yeah. Yeah. Oh, now I know we are playing with it a little bit. We're not like solving this one. This one requires some playing with because we're just kind of testing the waters. Putting it there might be able to pull us in a little better because it's just a little bit out of the way. Nah. Nah. Oh, gosh. We don't want to do this, do we? We're doing it at -10, -10 like I said originally. And then we like want this elliptical to pull us around. No, we just shoot off. We're dead. Oh my god. What if we do it at 15 though? Now I'm not even solving it. Now I'm just playing with buttons. But it seems like we're so close. It seems like we're just so close. Does seem like we're so close. But I thought it was a good idea to do this, to get it in here. And it kind of did work, but nah. Nah, no way. Way too slow. We're way too slow. Yeah, big elliptical here. So that's -7, -7. I wish I could save my like place and come back because I don't think we're gonna be able to do this one right now. This is my favorite attempt. The 7.3 I actually thought was clever, but I guess it wasn't as clever as I thought. This actually needed to be 15, didn't it? Because I'm going at 15, and it's kind of 15. So this is when we do this, it's 15, 15. This is 15, but actually, this is 14, 15. So we want to go a little bit stronger, but it doesn't work. That's what the 20 is for, right? It's the best thing we can do. I thought it was a good attempt. I really liked waiting that extra one little bit. This is the best one that we've managed to do. Where we come back around and we would have collected it kind of thing if we had an extra second. Oh no, this isn't the one. This is the one that's... we actually start following its orbit at that point, yeah. Is that the 15 one then? No, eh? Didn't we have this already? Weird. Okay. And if we were at 10 at speed? So if we did it at 10 speed. This one. So we have 10, 20, 6.28 plus 3.14. So yeah, we still have the 9.42. 9.4, and then plus another like quarter, half a quarter. So that was you know, speed of 10, radius of 20, 3.14. So another what, 1.3 0.57 here, the half. 1.6 extra, so 11, which we did before. And then this? Oh no, wait. Excuse me? That's why. Bit too strong. Excuse me? What are you doing now? Oh, we're going... What the heck? Why did that happen? Car position. Oh no, car position's correct. -20, 0. But this needs to be positive 10. It is positive 10. Excuse me? In that case... Radius of 20? 10? Oh, it needs to be 5. We were way out. So if we're slower, I guess we can get pulled into this field a bit easier. But we still wait until we're here to do that. Is this the one that almost did it for us? Or is this the one that's going to actually succeed? It actually did succeed. So how did we solve that? How did we solve that one? That was... What I was thinking is we do the same thing, but we need to go slower. We figured that out by testing. We had to go slower. There was no two ways about it. The speed was shooting us off into these weird ellipses. So I just tested it to go a little bit slower. But because it was 14, and that didn't really calculate correctly for us, the radius, we kind of just fit there in the middle, and we let the ellipses hit everything for us. That was cool. We solved it in the end, but that one was one that needed trial and error. It was the last... It looks like the last difficult one of the game, to be honest. That seems to be what it is until, number 8 appeared. So it does make sense, but it did require some trial and error, and I believe you needed to do some trial and error on that one. Whereas the other ones, if you could have kind of input them from just looking at the charts and thinking about it really, that one I think needed some trial and error. Here's Valentina Tereshkova, the first woman to go to space. Her only flight in space lasted nearly 3 days when she could barely move in her space cabin. It had the nickname Tin Can. Oh, yes. After her famous flight in space, Valentina Tereshkova worked as a pilot and as a researcher, publishing more than 50 scientific papers. She was also involved internationally in the promotion of women's rights. I do remember. No, I don't remember that, but I remember reading about that. The Tin Can, yeah. Sounds like a horrible nightmare, to be honest, trapped up there in space. Imagine if it didn't work. You'd just be entombed in a shuttle. Forever flying through space until you starve to death or whatever. That's awful, terrifying. But that's going to be the end of this video. We only have a couple more of these ones to do. These ones look a little bit simple, and I am excited to jump back into these 8. It only looks like doesn't even look like there's a level here. Looks like it's just to read about stuff. Here's the Sea of Crisis, the most easily spotted lunar sea. Is also the first sea to appear during a lunation. It's the first crescent. So what is this actually a level? So there are levels here. There are oh no. Maybe this is just end cutscene. Oh yeah, it looks like cutscenes. So we actually are at the end. We are approaching the end. I might just record the next video right now, but you're gonna have to wait. Thank you very much for watching. I think we've done it. I think we crushed this game. I think we did it. And it's been a ton of fun as well. I actually showed this to Kim, and she was like having some trouble with it and freaking out, but I did kind of just throw her right into the middle of it. But I've really enjoyed it. I've already recommended this to a bunch of people that I think might like it, like-minded people, but this is one that's special. This is very special. That story is honestly, I do not care about it, but the things that you can read about as well, the scientists and the history, but then also just the puzzles, I've just had a total blast with this one. Space Tow Truck, highly recommended. Go check it out. We have one more video coming. No, I doubt there's going to be one after that. But we'll see. We'll see. You know what this game could use? Oh my god, you know what this game could use? Community, like content, like a creator, a level creator. If this had a level creator, and you could just put it on Steam and people could just make thousands of their own levels, that would be so awesome. But anyway, I'm just gushing now. I'll see you next time. Bye.